Example 4, write a repeating decimal as a fraction. So I'm going to show you two ways of doing this. Um, but let's talk about what the repeating decimal is. So whenever I have a repeating decimal, it's got some decimal number of terms. Here it's got two of them. You can see it's 6 and 3. And when you put the bar over the top, it means take those two numbers and repeat them forever. Well, to me, triple dots there is the big clue. This is the pattern, right? So let's take a look at those first two terms there. That 3 is in the hundredth spot, which means I have 0.63 repeating equals 63 over 100. All right, that's the very first term. Now the next repeating portion, that 3 is in the 10,000th spots. So 6 is in the ones, 3 is in the tens, or sorry, uh, um, tenths, hundredths, thousandths, 10,000ths. So that means for the second term, I have 63 over 10,000. Right? See how that's working there? Next one, I'm just going to add two more zeros to it because it's taking up two more spots. So I got, instead of four zeros now, I have six zeros. 1, 2, 3, 4, 5, 6. And next one, add two more zeros, 63. And I'm going a little bit overboard here. But it's just to kind of build up and demonstrate the pattern here of what's going on and adding those up forever. So if I'm looking at it this way, I notice it's a geometric sequence that's infinitely long. So it's an infinite geometric sequence. What's the common ratio? Well, if you think about it here, to get in between each one of these terms, I'm adding two zeros to the denominator, which means I'm multiplying it by 1 over 100. So there's my common ratio. And the common ratio for these kinds of problems are always going to be how many decimal places are you repeating? It's going to be 1 over that many decimal places in terms of hundreds. Like if it was three decimal places repeating, it'd be 1 over 1,000. If it was five decimal places repeating, it'd be 1 over 100,000. Right? So that's the idea. Same, just the number of zeros should match. And I know the first term. Well, that should be enough to tell me that the sum is 63 over 100 over 1 minus 1 over 100. And that's going to be 63 over 100 over 99 over 100. There's an interesting thing that's going to happen here. When I flip the second and multiply, the 100s are going to cancel out. So I'm left with 63 over 99. And both of those are divisible by 7, I think, or they're both divisible by 9. They're both divisible by 9. 63 divided by 9 is 7. And 99 divided by 9 is 11. So 0.63 repeating as a fraction is 7/11ths. Pretty neat, right? So that's the first way of solving this. Let's go ahead and take a look at the second way. And this way is actually quite fun. I have 0.63 repeating. Well, I'm just going to say that that's x, right? Why not? It's x. You know what I'm going to do? I'm going to multiply both sides by 100. Why 100? Well, there's two decimal places there, and that's in the hundredth spot. So Let's multiply it by 100. So I get 100x equals 63 point, well, that 63 was repeating forever, so I'm just going to repeat that 63 forever again. Well, if you notice, I now can just subtract that 63 repeating forever from both sides, right? Minus 0.63 repeating forever. It's a number. I can subtract by it. That's totally fine. But we also know that that's equal to 1 to x, isn't it? So instead of writing minus 63 minus 0.63 repeating on the left side, I'm going to say subtract x. And I'm allowed to do that because I said in the beginning x equals 0.63 repeating. I said they're equal to each other, so I can do that. I'm doing the same thing to both sides of the equation. So what am I left with? 99x is on the left, 63 on the right. Divide both sides by 99. You get x equals 63 over 99. And guess what? That reduces down to 7/11. So you can do it with an infinite sum, or you can do it with basic algebra. It's just that blue step in there, that's a really tricky step. So if you didn't understand that one, stick with the infinite sum. But that's how you can convert a repeating decimal into a fraction.